Frequency modulation is another simple synthesis technique that is actually simple yet quite effective. And in frequency modulation, or FM synthesis, we are changing frequencies with other frequencies. And if that doesn't make sense, it will in a moment. So when we have a frequency generator, like a sine wave generator, like cycle, so we put a frequency information in cycle tilde, and it gives us something that repeats over a certain amount of time, right? So what frequency modulation does is to control this signal with another signal. So the signal frequency value, for example, you can put any number here, and let's put maybe a scope tilde to see the waves. And if we turn on our DSP and give cycle tilde a certain amplitude, like let's keep it low, you will see like normal sine wave shapes, right? But so the idea of frequency modulation is to control this value and make this guy oscillate with another oscillator. So what we're going to do is we're going to create another signal, let's say sig tilde, and attach it to our cycle tilde. So cycle can take either numbers or signals, so it doesn't really matter. For the cycle tilde object, for frequency modulation, we're going to use sig tilde, and then we're going to add an oscillating frequency to this sig tilde. So let's use a plus tilde object and squeeze that between here. And this wave generator is called the carrier frequency. So this is going to be the flat base of the frequency information. And then this wave generator, we're going to call this the modulator. And the modulator will start changing the frequencies of, changing the number of the frequency information. So we can say, for example, let's just take it as it is for now. And let's just say when we add the frequency information with another signal, like let's say for 1 Hertz, what you're going to see on the scope is that the wave shapes are not symmetrical anymore. They're opening and closing. Some of them are wider, some of them are more narrow. And this is because we are alternating the frequency value, which is 5 on the carrier, with a 1 Hertz frequency on the modulator, which means the main signal will be changing between 4 and 6 Hertz. So we can use a number tilde object and attach it to the end of our plus tilde object. And then you will see that the frequency for the carrier wave is swinging between 4 and 6. So these are all low frequency oscillations, right? We are not going to be able to hear sound from these low frequencies. But if we increase the frequency to something we can hear, for example, 100 Hertz, so you can see the waves are getting crazier, but the modulation is still 1 Hertz, right? And the modulation depth is still 1, meaning it's going +1 and -1 away from the carrier signal. So we want to add more depth into this signal so we can change it faster. So right now it's swinging between 99 and 101 every second. And if we give the modulator 2 Hertz, it will modulate between the values 2 times a second, or 5 times a second. But with higher frequencies that we can hear, these kinds of swinging may not be so audible. Let's actually let's make a gain and a easy DAC. And then connect all of them together. take the gain down, and turn on your DSP and raise the volume. And you should be able to hear a tone, and it's actually being modulated 5 times a second. But you will not be able to hear it because the change is so small. So that's why we use a amplitude. We define an amplitude for the modulation. Let's just say 0 for now, and put that between the cycle and the plus objects. And now we can attach the float box, and now we can adjust the depth of this modulation. So let's say instead of 1, let's make it, I don't know, 20. Now you're able to hear a wobbling, shifting frequency. And this is frequency modulation. Well, what makes it more interesting is that let's create a sonogram, which we can do with a spectrogram tilde, spectroscope tilde. Oh wow, my computer's slowing down again. So let's make this spectroscope logarithmic again, but also I'm going to change it to a sonogram display. So this is going to give me another way of visualizing the signal, in that instead of having the frequencies go from left to right and observe the peaks, we have the frequencies from bottom to top. So you have these like sliding, shifting bands. So over time, the intense frequencies will be darker and the empty frequencies will be brighter. Okay? So now we can increase the modulating frequency. And now, instead of a wobbling, you hear something that is closer to a steady tone. It's a bit gritty, but if we further increase the frequency, it will become more and more of an audible tone. And now you can also change the amplitude of the modulation. Let's call it amplitude of modulation, like so. And then we can also label the frequency of the modulator and then the frequency of the carrier. Okay, so if we really max out the amplitude of the modulator, now you're gonna hear and also see that you're getting more partials in the sound. So now you're really starting to distort the waves and shape them in ways that are sort of irregular. So they're creating more tones and partials in that sound. And let's also create an envelope to control the amplitude of the carrier. Okay, let's make a function and then line tilde, hook this up here, and then have a multiply tilde in between here, and then attach the line tilde there, and then draw an envelope, and then maybe let's have a K slider so we can press some notes and have a MIDI to frequency conversion, and then attach that to our frequency. Okay, so now we are ready to play some sounds, play some notes, and use some amplitude modulation. Let's keep these values maybe 100 and 50, and then we can press the notes and trigger a bang after a float so that we are triggering the envelope. Okay, so now we can play some notes. Increase the frequency modulation. Even max it out, make it extreme. Make the amplitude a bit more extreme. Make it really slow, really shallow, maybe like 30. Maybe let's take this to 1000. So you have all these kinds of weird changing tones and partials depending on the depth of the modulation and the frequency of the modulation. And you just add that onto the carrier wave and you will perform frequency modulation. It's as simple as that. And that's going to be it for FM synthesis.